how do we write an Unicode character to a disk? How we convert it to binary? Let's imagine that we have this code point. This corresponds to the A, and we want to convert it to binary numbers to store it in a file or to send it over the network, whatever. So one approach could be to just convert the code point number to its binary form, for example, just a natural number. But remember that we have in Unicode, we can have this number of characters. Okay, the last code point is this one. So how many bytes would we need for storing this code point? Well, this would be a byte, this would be another byte, and this will be another one. So we'll need 3 bytes for storing a single character. Remember that and that when we were using the ASCII table, one character was stored as 1 byte. So if we use this approach, we are multiplying by 3 the amount of space that textual information will need. So Unicode, what did is define 3 different codifications. The codification they defined was UTF-8, UTF-16, and UTF-32. The rules for transforming one code point to each one of the codification are not simple, and you don't need to know them. But what is really important here is that the codifications, the first codifications, the UTF-8, is the most widely used today in computers. Is optimized for characters that mostly belong to the ASCII table. So the characters, or the representation of a character will occupy between 1 and 4 bytes. The, the UTF-16 is optimized for characters that don't belong to the ASCII table, and they will occupy between 2 and 4 bytes. So if we are using mostly characters in this range, it will be better to use this codification because the most part of the characters will be occupying just 1 byte. But some of them will occupy 3 to 4 characters, but we will minify the amount of space required to codify the different code points to the disk. If you are using mostly characters that are not in the ASCII table, probably it will be better to use the UTF-16 because you will be using a minimum of 2 bytes by each character, but you will require less characters will require 3 or 4 bytes, so it will be it will be better. It will be as you will need a smaller amount of information to store that the code points. The last codification is UTF-32. UTF-32 will use always 4 bytes for storing each code point, each character. So no matter what character we have, it will use always 4 bytes. So we are multiplying the amount of information needed for store each character by 4 compared to ASCII. Why by 4 and not by 3? I don't know. It's a mystery of the standard, and I think it makes some sense for somebody there. But it will use always 4 bytes for each character, and it's not used very much. I think the most used codification is UTF-8. After that, UTF-16. I think I haven't seen this kind of codification ever, but it's useful that you know it.